That's a better pen size. So we're going to look at our inverse cosine of 1/2 first. And there we go. So when we're looking at that, we're wanting to see what angle on the top half of our unit circle has a cosine of 1/2. That is a unit circle value. So our cosine of positive 1/2, that's going to be our angle pi over 3. So the angle that has a cosine of 1/2 means this is pi over 3. So what we're really being asked to find is we're asked to find our secant of pi over 3. Well, secant, we know that is our reciprocal of cosine. Well, we know our cosine. Our cosine was 1/2. So to get our 1 over cosine of pi over 3, that's a 3. I'll do it like that. That's really telling us to do 1 over 1/2. So this whole thing is going to simplify down to be just 2, the reciprocal of 1/2. So start from the inside and work your way out. Look from the inside piece, see if we can figure out if it's an inverse, what angle it is. If it is not an inverse, that's when we're looking for our ratio, which is either a unit circle value or we're going to build a triangle. So if there's an inverse on the inside, it means we're looking to find our angle first. So in this case, when we have inverse cosine of sine of 5 pi over 4, when we look for our inside piece, that means we're going to start by finding our ratio, our sine of 5 pi over 4. Well, 5 pi over 4, that's one of our unit circle values. So this is on our unit circle. Sine of 5 pi over 4, we know that. That's our quadrant 3. Our sine, that's our negative root 2 over 2. So when we're looking to find inverse cosine, we're saying, oops, sorry, my screen's freaking out. There we go. Let me fix the view so you guys can see the whole thing. There we go. All right, so now we should be finding our inverse cosine of negative root 2 over 2. So when we think about inverse cosine, we're thinking about our top half of our unit circle. Cosine, we're looking up here. So we're looking which angle in this portion of the circle has a cosine of negative root 2 over 2. Well, that's going to be this guy over here, which is our 3 pi over 4. So inverse cosine of sine of 5 pi over 4 equals 3 pi over 4. So work on them in isolation, like take little bits. Don't try and do it all at one time. Take them in little pieces and work them bit at a time. Okay. Any questions on these two? I see a little dot in the chat. Okay. Oh, fun. My screen's being grumpy again. We love that. Must be a fly in here that landed on the screen or something. Love it. All right, let's do a couple more like that. And then I'll do one big one. Oh, my goodness. Did not touch the screen. Nobody's over there. I don't even see anything flying around. My screen's just being grumpy. All right, so let's look at inverse tangent of cotangent of 2 pi over 3. So we start from the inside. So our first thing we're going to look at is cotangent of 2 pi over 3. Well, cotangent, that's our reciprocal of tangent. So we want to find our tangent of 2 pi over 3 first so that we can take our reciprocal. Or you can do it by hand, manually do it and do cosine over sine instead of sine over cosine. That works too. But as I say, this tends to be the way that my brain works. So if I find tangent of 2 pi over 3, that means we're going to come into our 2 pi over 3, and we're going to get that our sine, that's our root 3 over 2, over our cosine of minus 1/2. So that means our cotangent of 2 pi over 3 is negative 1/2 over root 3 over 2. And we absolutely could simplify this. We absolutely could. But I know since I'm doing an inverse over here, I'm going to keep it unsimplified so that it's easier for us to spot things. Because now what we're asked to find is we're asked to find inverse tangent, which I just tried to put an I in the middle of the word tangent to say inverse. So our inverse tangent, we want to know what angle is going to have the ratio of negative 1/2 over root 3 over 2. And so by not simplifying it, it's actually easier to kind of find, because looking on our unit circle with tangent and sine, we look at our right half. We can see that since we have a negative here, we're going to be definitely looking in quadrant 4. So we want to know which angle has a sine of negative 1/2 and a cosine of root 3 over 2. So our one that has a sine of negative 1/2 and a cosine of root 3 over 2, that's going to be our 11 pi over 6. But that's not in our domain here. We want to keep this between our minus pi over 2 and our positive pi over 2. So thinking through our unit circle helps us find our angle, but in order to get it into our domain of our inverse, we're going to put this as a minus pi over 6, which is coterminal with our 11 pi over 6. It's just in our domain. So we got to make sure we get it into the domain. That's probably the trickiest parts of these inverses, is making sure we wind up with our angle being in the quadrant we want it to be in with the right signs. So our answer on this one is a negative pi over 6. There's a little barrier here. All right, one more like this, and then I'm going to show you one other way that they like to give us problems. So we've got cotangent of the inverse cosine of negative root 3 over 3. So inverse cosine of negative root 3 over 3, what that tells me is we're looking for our angle, and we know that cosine of some angle is negative root 3 over 3, which is not a unit circle value. It's close. Root 3 over 2 is a unit circle value. So it's close, but it's not quite there. So what that means to me is we are going to set up a triangle so that we can look at the pieces. We know that inverse cosine, we're looking at the top half of a circle, and since it's negative, we're going to be looking at quadrant 2. So I'm going to face my triangle this way. This is the angle we're looking at. We have our cosine, which means we know our adjacent is our negative root 3. And we know our hypotenuse is a 3. And we can use the Pythagorean theorem to figure out what our other leg is over here. We're going to have our negative root 3 squared plus our b squared. Oh, I'm way too close to the edge right there. Hold on a second. Let me squeeze this over. Should equal our 3 squared. So that means we're going to have 3 plus b squared equals 9, which means our b is going to be the square root of 6. So this guy is square root of 6. Since we are in quadrant 2, that is going to be positive. My y values are positive. So when we're looking to find cotangent of theta, we can use our triangle. We could find tangent and go from there. We can do it however we want, but we're trying to find our cotangent of theta. So tangent is our opposite over adjacent. So cotangent is adjacent over opposite. So setting it up as a pure fraction, we're going to have our negative root 3 over root 6. If I could leave radicals in my denominator, we'd be good to go, and we could stop right there. But we do need to rationalize this. So we're going to multiply by root 6 over root 6 to get my denominator to not have any radicals. So our cotangent of theta, we're going to get our denominator of 6, which is what we want, and we have negative root 3 times root 6. We can multiply those guys under the radical, and we're going to get square root of 18, which is valid. We can do it like that. It's not fully simplified. Fully simplified would be to realize that there's a perfect square of 9 in there that we can factor out. So this is going to be negative 3 root 2 over 6. Also, the yellow calculators will simplify this for you. Just make sure we see what's happening here, because what we actually have here is negative root 2 over 2, because the 3's and the 6 cancel out. So this is our fully simplified answer. Here's negative root 2 over 2. Okay, I want to show us one more, last one, for the chapter. It's taking our inverses and combining it with our angle sum. So it's a little icky, but we can do this. So they're asking us for the cosine of inverse cosine of 1/2 plus inverse tangent of 3/4. These inverses are angles. This is going to ask us, I'm going to call this one angle alpha, and I'm going to call this one angle beta, because we're looking at two different angles here. So inverse cosine of 1/2, we can do that. Inverse cosine of 1/2, the angle that has 1/2 as its cosine, that's going to be our pi over 3. Tangent that, or the angle that has a tangent of 3/4, that one's not a unit circle value. So for our beta, we can draw our triangle here. So we're going to look at our angle beta. I know this is tangent, so we have our opposite of 3, our adjacent of 4. And if we look closely, this is a 3, 4, 5 right triangle. The reason that that's helpful is because when we're asked to do our cosine of this sum, what we're really doing is we're going to bust out our angle sum formula, where we have our cosine of alpha plus beta is our cosine alpha cosine beta minus sine alpha sine beta. You can also set this one up as a triangle if you'd like to. That's totally fine. But we know pi over 3, so I know cosine of pi over 3, and I know sine of pi over 3. I've got my whole triangle for beta over here, so we can find cosine of beta and sine of beta, which is exactly what we're going to do. cosine of alpha, cosine of pi over 3. Cosine of pi over 3 is our 1/2. Cosine of beta, cosine is our adjacent over hypotenuse, so we're going to have 4/5. Sine of alpha, sine of pi over 3, that's going to give us our √3/2. And our sine of beta, opposite over hypotenuse, is going to give us 3/5. So when we come through to simplify these, we're going to have our 1/2 times 4/5 giving us 4/10. And √3/2 times 3/5 is going to give us 3√3/10. And you can write it like this. We can also combine this together to make one gigantic fraction. So we're going to have our 4 minus 3√3 all over 10. So you can either go this direction and simplify it into two separate fractions, or you can put it here. But since we're looking for our exact value, what that means is do not round this off. Do not put it as a decimal. Sorry, my Roomba is throwing a fit over something. And it is too far. Oh, there we go. I finally caught it with the remote. I think it found a pencil. Love to have it. Okay, but so when we have something like this, leave it with the radicals. Do not put it into decimal form. Only if we specifically ask you for decimals should you put it in decimal form, which we typically won't. At least not unless we're doing a story. But at this point, we don't have stories for these. So leave it as a radical. Do not switch it to decimal. You can write it like this, or you can do it in two separate fractions. In which case, we would need to simplify this one. Okay? So what you guys have is about 4 minutes left in the period. I have posted a blank copy of the chapter review. I've also gone ahead and gotten all of the answer keys up and posted. If you find any mistakes on them, please feel free to reach out and let me know. I definitely have been known to make mistakes on the reviews. I'm trying to get them out before you guys get them all the way done, but that means sometimes I go a little too fast. So please, 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 if you find something that's off, reach out and let me know. Tomorrow, we're going to have the whole time to work and ask questions because our exam's on Thursday. Okay, so those are all the things we needed to do. That covers all of our stuff. We can do this. Y'all are awesome. You're rock stars. I will pass back absolutely everything that's been turned in tomorrow. I'm going to pass back the old quizzes. I'm going to pass back everything from Chapter 7. Everything. I have all the homeworks in. All I got to finish up is Quiz 6, and then I'll get everything organized and ready to pass back to you first thing tomorrow. All right? So work on stuff. If you're working through stuff today and you got questions, please, please, please send me a message. Canvas, Parent Square, email, whatever you got. All righty? Have a good day.